Hi, I'm Mei Chen from National Taiwan Normal University. I'll briefly talk about our work, a semi-supervised learning approach for traditional Chinese syntax detection. So the goal here is to detect all of the text areas in images. So here I showed you of just a few examples. It's quite challenging because texts are quite diverse in color, shape, style, and many factors. So there are several text detectors in the literature. However, most of them focus on English, which may not be applicable to other languages. For example, in Chinese, there are 5,000 to 6,000 characters, and that's a large quantity of words. And also, like most object detection tasks, the cost of annotating or responding boxes of text areas is high. So in this work, we explore a semi-supervised traditional syntax text detector. We also synthesize new samples from annotated samples to create the richness of our training sets. So our approach was developed based on unbiased teacher, ICLR work on semi-supervised object detection. It has two stages. Also, in the birding stage, we trained a based text detector using YOLO v5 on label data. And now in the teacher-student mutual learning stage, we duplicate this base detector into two models, a teacher model and a student model. The teacher model receives the unlabeled data and to create pseudo labels for them. And now all the pseudo labels and the label and synthesized data go for strong data augmentations to create a diversity of the training sets, then feed them to the student model. So now the student takes a more challenging task to detect the text in these images, but it's also expected to generalize better. The weights of the student model is transferred back to the teacher model steadily through the EMA strategy. So in this loop, the teacher keep improving the quality of pseudo labels. The student now take more training set and keep improving itself. So in this stage, teacher and student models could benefit from each other. Finally, we use the teacher model for inference. Some details about the data augmentations. We found mosaic is particularly effective in this work, in which we put 4 different images into one to create the diversity of the training sets. We also create more training samples by replacing text areas of certain images with those from the others. The experiment was conducted on the AI Cup datasets that was developed to support a domestic competition in Taiwan. We used precision recall in F1 to look at the performance. So this slide showed you that the effectiveness of this semi-supervised approach. So it no matter which model is used, it brings about 2 to 4% of improvements in comparison to the supervised baseline. We also have conducted several ablation experiments to understand the effects of each design choices in this work. So if you're interested in, please welcome to stop by our poster, and I will be happy to discuss it. Right, so in this work, we present a semi-supervised traditional Chinese syntax detector. This detector was developed based on a teacher-student mutual learning framework. We found that data synthesis and mosaic can further improve the detection performance. That's it. Thank you for your attention.